Beginning with some exponent rules. If we're just multiplying and they have the same bases, we add the exponents. When we divide and we have the same bases, we subtract the exponents. When we have a power rule, we take the base of a power to a power, we multiply the exponents. Power of a product rule, we distribute the exponent to both factors. Power of a fraction rule, we distribute the exponent to the numerator and denominator. Zero exponent rule, any non-zero number to the power of 0 is 1. And negative exponents, we've got a couple ways to look at it. If I have a negative exponent in the numerator, it belongs in the denominator. And when I put it on the other side of the fraction bar, the exponent becomes positive. Or if I have a negative exponent in the denominator, it belongs in the numerator, and when I bring it up top into the numerator, the exponent becomes positive. Now let's walk through an example. First thing is we separate the different things that we're working with. So 12 over 15 is just numbers, x to the 7th over x to the 12th. Simplify the fraction with numbers. 12 over 15, I can divide them both by 3. So that gets us 4 over 5. Figure out who has more x's, the top or the bottom. The bottom has more. It has 5 more, and so we leave that in the denominator. And then we put our answer together, and we end up with 4 times 1, or 4 on top, and 5 times x to the 5th on bottom. So our end answer is 4 over 5x to the 5th. Second worked example. Note it's all multiplication, so we add the exponents. So that gets us x to the negative 4 plus negative 3 plus 3 plus 4. Simplify that adding, and that gets us x to the 0. And any non-zero number to the power of 0 is 1. Third worked example. Simplify between the k's on the inside. We've got more k's on the bottom, so we would leave t to the 4th on top, and we would have k to the 1st on the bottom. Then we've got a t with a negative 1 on the bottom. Send it to the top. That gets us t to the 1st times t to the 4th on top and k to the 1st on the bottom, all inside to the power of 4. And then we can simplify that top part to t to the 5th over k to the 1st. Then we distribute the power to every power on the inside. And so that gets us t to the 20th and k to the 4th, because we multiply. Last worked example for exponents. First, start with the top and send any negative exponents to the bottom. So that leaves just the p to the 6th on top. The 3 to the 1st and m to the 4th get sent to the bottom. Second, send any negative exponents on the bottom to the top. And so we get that m to the 1 and p squared on top with that p to the 6th. Simplify the top and bottom. So that gets us p to the 8th on top with m to the 1st, and on the bottom 3 to the 4th and m to the 4th. Cancel common factors between the top and the bottom. We've got more m's on the bottom than top, so that would leave us with m to the 3rd on the bottom. And we can stop there. That's our end answer. We could take 3 to the 4th and multiply it out. It would just be 81, but we're good with that. Practice, I've got 4 of them. I want you to work through the same type of questions we just did. Rules for simplifying. We have to work with order of operations. We replace all of the x's with the number, and then we follow the order of operations and simplify. First in the order of operations is take care of anything in parentheses or grouping symbols. Second, take care of any exponents. Third, take care of all multiplication and division from left to right. Last, take care of all addition and subtraction from left to right. Worked example, f of x equals negative 2x squared plus 4x minus 1, and we want to find f of negative 5. Plug in negative 5 for all the x's. Grouping symbols first, which there's nothing to do in the grouping symbols. There's no adding or subtracting or multiplying. Then we take care of the exponents. So that gets us negative 5 squared, which is positive 25. Then we take care of multiply and divide from left to right, which we only have multiplication. So negative 2 times 25 is negative 50. 4 times negative 5 is negative 20. And then we add and subtract from left to right. Negative 50 plus negative 20 is negative 70. Negative 70 minus 1 is negative 71. And we write our answer as f of negative 5 equals negative 71. Basic rules for solving equations. We perform the order of operations in reverse order. That means undo the last operation first. There's an extra rule for solving inequalities. Whenever you multiply or divide by a negative number, switch the inequality symbol's direction. So here we've got an equation. First step is simplify both sides. So that means get rid of those parentheses. So 5 times 2x times 6 is 10x plus 30. And then on the right, negative 4 times negative 5 is positive 20. Negative 4 times negative 2x gets us plus 8x. And then we've got that plus 3x. We can simplify again. Left side just stays 10x plus 30. The right side, 8x plus 3x gets us 11x. Move the smaller x. 10x is the smaller x, so subtract it from both sides. And simplify, we get 30 equals 20 plus x. Subtract 20 from both sides to get x by itself, and we end up with x is 10. Now working a inequality, some of the same steps. Simplify both sides. So distribute that, subtract that, multiply by negative 2 through the parentheses, gets us negative 2x plus 16 on the right. Simplifying again gives us 18 minus 2x. Move negative x to the other side, so I'm going to add x to both sides. That gets us 23 is less than 18 minus x. Move the 18 to the other side, so subtract 18. That gets us 5 is less than negative x. Get rid of the negative with the x, that means divide both sides by negative 1. When I divide by negative 1, don't forget to flip the inequality symbol's direction. So that gets us negative 5 is greater than x. Another one with working inequalities. We're going on a field trip and need to choose where to go. The zoo charges a $100 fee plus $10 per student. The museum has a $250 fee plus $5 per student. How many students need to go on the trip in order for the museum to be the better deal? So start with identify a variable. I'm going to let x equal the number of students. Set up the cost for the zoo. Well, that's $100 plus 10x for each student. Set up the cost for the museum. Well, that's going to be $250 plus 5x. Then we set up the inequality. We want the museum to be the better deal. That means we want it to cost less. So we want 100 plus 10x to be greater than 250 plus 5x. And then we solve. So I'm going to subtract 100 from both sides. Then I'm going to subtract 5x from both sides. That leaves us with 5x is greater than 150. Divide both sides by 5. We end up with x is greater than 30. Right, our answer, more than 30 students need to go for the museum to be a better deal. And here are 4 problems that I would like you to practice. We also work with identifying slope and y-intercept from an equation or graph. From an equation, we want it in y equals mx plus b format. Whatever number is in front of x is your slope. Whatever number does not have an x is your y-intercept. From a graph, wherever it is crossing the y-axis is your y-intercept. And slope is rise over run, so we count from one point to the next point. How much do we rise? And in this example, we rise up 1. How much do we run to the right? We run over 2, and that's why the slope is 1/2. We have some special types of linear equations. We have horizontal lines, like this y equals 3. The slope is 0, and the y-intercept is wherever it touches the y-axis. This case would be y equals 3. The vertical line, x equals -2, the slope is undefined, and it has no y-intercept because it will never cross the y-axis. Now we've got some worked examples. Identify the slope and y-intercept. Well, it's in y equals mx plus b format. So identify the number in front of x. This is the slope. So our slope is 4/3. Identify the number without a variable. This is our y-intercept, and that would be -7. Notice how I wrote this as an ordered pair, 0 for the x and -7 for the y value. Next one, same thing. Solve for y first because this is not y equals mx plus b. So here I'm going to subtract 2x from both sides. We have -2y equals -2x minus 14. Divide everybody by -2. That leaves us with y equals x plus 7. And then we identify the number in front of the x. This is our slope. Since there's no number sitting in front of the x, that's automatically a 1. Identify the number without a variable. That is our y-intercept. In this case, it is 7. Again, I wrote that as an ordered pair, 0, 7. We can also find it from a graph. Find the y-intercept, see where it's hitting the y-axis. It's hitting at 0, -5. Then pick 2 points. The line goes through and count the rise and run from point to point. So we've got the point 0, -5 and 1, -3. The rise, we rise up 2 to get from -5 to -2. The run, we run to the right 1. So our slope is 2/1. Write our answer. Slope is 2, y-intercept is 0, -5. We can also find slope and y-intercept from a table. Find the y-intercept. So we're looking for where x is 0. That happens to be at 0, -0.5. Pick 2 points the line goes through and count the rise and run from point to point. So I just picked 0, -0.5, and 1, 0. To get from -0.5 to 0, we rise up 0.5. To get from 0 to 1, we run to the right 1. So our slope is 0.5/1, or just 0.5. Writing our answer, our slope is 0.5. Our y-intercept is 0, -0.5. And then here is some practice. I'm asking you to do the exact same things. Find the slope and y-intercept for each of these equations. Some review of geometry, just some of the terms. An acute angle is an angle between 0 and 90 degrees. An obtuse angle is between 90 and 180 degrees. A right angle is exactly 90 degrees. A straight angle is exactly 180 degrees. That's why it looks like a straight line. That's why it's called a straight angle. Complementary angles are two angles that add up to 90 degrees. Linear pair, supplementary pair, they're very similar. A linear pair is two angles that make a straight angle, which means they're also supplementary, means two angles that add up to 180 degrees. Adjacent angles are two angles that share a side. Vertical angles are two angles that are formed by intersecting lines and only share a vertex. Vertical angles are also congruent to each other. Interior angles of a triangle, all three interior angles of a triangle sum to 180 degrees. Now, identify type of angle relationship, then find the missing measurement. So identifying the type of angle relationship, these two are adjacent. They also are a linear pair. That means they're also supplementary. Write an equation. That means b plus 50 should equal 180 degrees. Solve, subtract 50 from both sides. We get b is 130. Write our answer. B is 130 degrees. Next one, same thing. Identify the type of angle relationship. These are vertical angles. The equation then is that they are equal to each other, so 2 plus 3x equals 62. Solve the equation, subtract 2 from both sides. We get 3x equals 60, divide both sides by 3, x is 20. Write our answer, x is 20 degrees. And here I've got 3 that I want you to work through on your own. And the last type of thing that we're reviewing in foundations is rigid transformations. Rigid transformations preserve angles and side links. There are types of rigid transformations: translations, which slides it around, reflection, which is a mirror image, and rotation, spins about a point. Translation, if you shift it left or right, you change the x values of the points. If you shift it up or down, you change the y values. Now, a reflection usually is across the line. And some common reflections across the x-axis, notice just the y values change their sign. Across the y-axis, just the x values change their sign. And across the line y equals x, we end up switching X and Y. Also rotation, usually it's always about a point, and we usually talk about it going counterclockwise. If we rotate 90 degrees about the origin counterclockwise, the new ordered pair would be switch X and Y and change the sign of the Y value. About the origin and 180 degrees, we just change the signs of the X's and the Y's. About the origin, 270 degrees, Y and X change, but the X changes its sign. And to go clockwise at 90 degrees, notice this is clockwise, that would be the same as counterclockwise 270 degrees. Here we want to rotate 90 degrees counterclockwise about the origin. First, identify the points of the object. So we've got point J, which is at -5, -2, L, which is at 0, -3, and Z, which is at -4, 0. Find the pattern from the notes. Since we're going 90 degrees counterclockwise, I would be working with this, which means I need to switch my X and Y and change the sign of the Y. And then we write our new points. So for J prime, I switch the -5 and -2's order, and I change the sign of the -2. Do the same thing with L, which gets us 3, 0. Do the same thing with Z, but when you switch the sign of 0, that's still 0. Here's another one. We want to describe the transformation. Identify the type. Well, it looks like a reflection. Identify the line of reflection. Well, right there, that purple line cuts it in half. That's the line X equals 3. And then we write the rule. It's a reflection across the line Y, X equals 3. And then we have practice for you. We've got 2 different triangles, and I want you to tell me in 3 transformations. One of them will be a translation, one will be a reflection, and one will be a rotation to get the red triangle to the blue triangle, to get them to overlap.